Okay, in this problem we have the equation y equals negative times x plus 2 times x minus 4. So we have a quadratic equation given to us in factored form. And as soon as we notice in factored form that that a value is negative, then what we know is that our parabola opens down. And our goal now is to be able to find the roots, the axis of symmetry, and the vertex so that we can complete the graph. If I use the zero product property, I can see that I have an intercept at -2. I also have an intercept at 4. So I'm going to go over to my graph at -2, 0, and at 4, 0, those are my intercepts. I can now take n, knowing that if I have an intercept here at 4 and here at -2, that my axis of symmetry must be between these 2 points. I'm going to take and add these 2 together and divide by 2. And what happens is that I now know that my axis of symmetry is at x equals 1. That's the vertical line. In addition, I know the x-coordinate of the vertex is 1. So I'm going to take a minute. I'm going to draw in my axis of symmetry at x equals 1. Now I need to find the y-coordinate of my vertex. And so if I was given the original equation, and I know the x-coordinate, I can now take and plug in 1 in place of x. So here was my a value, -1. Simplifying that parenthesis, simplifying this parenthesis. If I multiply those all together, that's going to give me a y value of 9. That y value is the y value of the vertex. If I go over to my graph here, here is -1, 9. I can now see that that vertex is going to be a maximum value. I knew that because it was open up also, so I knew that value was going to have to occur there. If from the vertex, I move to the right 1, 1 squared is 1, move down 1, use symmetry, go back to the vertex, move to the right 2, 2 squared is 4, count down 4, use symmetry, go back to the vertex, go to the right 3, 3 squared is 9, when we count down 9, we are at our x-intercepts. And so now we can use these points to draw that U-shaped curve that is our parabola.